All right, we're going to start Unit 8 here. Unit 8, Lesson 1 for Pre-Algebra. In this video, we're going to be talking about functions. Let's get started. So what is a function? Well, a function is a special type of a relation. Oh, let me change. I was playing with some art stuff earlier. Let me switch to this brush. It is a special type of a relation. It's a relation between two sets. So we could have a set over here that was maybe had 3, 4, 5 in it. And then we could have another set over here that had 8, 9, 10 in it, maybe. You can have whatever numbers or whatever else. And specifically a function is a relation which for every input, these are inputs. I'm getting a little crazy with my colors here. For every input into the function, there is only one output. So maybe this could be mapped to where if we put in a 3, we get out an 8. If we put in a 4, we get out a 9. Put in a 5, we get out a 10. Right? So this could be a function, right? Because for every single input, there's only one output. Let me clear off all of this and shrink my brush back down. So the inputs of a function have a couple other names. They're the inputs. The list of all inputs is called the domain. And they are, and the variable part, the parts of the domain are the independent parts. Independent parts. Okay. So in this example, we might have a -2, 0, 15, 18. Okay. And then over here, we might have the outputs of a function. Function is kind of like a machine where we stick stuff into the function and then we get something out of the function. 3, 5, 12. Sounds great, right? These are the outputs, just like we had on our last sort of slide. The list of all outputs is called the range of a function. And they are the dependent quantities. And it's usually easier to figure out which variable or quantity is the dependent one because it depends on the other one, right? A lot of times, like if we're trying to do a function of distance traveled by time, well, the amount of distance that you travel depends on the amount of time you've been traveling, right? Or that kind of thing. We'll see as we continue talking about this more and more examples where we're looking at the independent and the dependent quantities. The independent one goes with the domain, which are the inputs. The dependent one goes with the range, which are the outputs. Now, for it to be a function, it's got to be 1-to-1. So for every input, there is only one output. Okay. Let's do a couple of these bubble diagrams so we can see some examples of ones that are and are not functions. Sound good? Yes, it does. I think so. So let's do example 1 over here. Example number 1. Say we have this bubble diagram, 0, 5, 12. And we're going to map that to this one, where we have 3, and 6. And let's map it this way. If we put in a 0 into the function, we get out a 3. If we put a 5 into the function, we get out a 6. And if we put a 12 into the function, we get out a 6. Now, so is this a function, yes or no? Right? A function, yes or no. Now, I'm going to write another one up here. Let's do a different color. Let's do a green one. Example number 2. We're going to do this one a little bit different. Let's do one where the domain is -588 and the range is -2, 6, 18. And let's compare these two. So on this one, we're going to map it this way. If we put a -5 into the function, we get out a -2. If we put an 88 into the function, we get a 6 and a 12. So is this a function? Yes or no? So one of these is a function and one of them is not. Now, the one that's not a function, you may have already guessed, is this green one over here. Okay, so for this one, we have one input giving us 2 different outputs. So even though these 2 inputs have, on this number 1 over here, even though these 2 have, they have the same output, for each input, there's only one output, right? So X doesn't repeat. Oh, that's another thing we need to add to our notes from earlier. Let me go back and add that. Not those ones, these ones. The input, also the domain, the inputs also relates to the X variable. And the range, the outputs, the dependent relates to the Y variable in a function. Okay. So this pink one over here, the answer would be yes, it is in fact a function. So yes, it is a function. This green one over here would be no, it's not a function. Let's look at a couple other examples in a couple of different forms. Let me see if I can find what I'm looking for. I want that and that. All right, so we have 2 different examples here. Up here at the top, we have a relation that is a set of ordered pairs. Ordered pairs, in case you don't remember, go X, Y. So this would be the inputs, the domain. This would be the outputs, the range. And then we've got here essentially a list of ordered pairs, but listed as a table, right? And so we want to know, are these functions? So let's look at this blue one first. So as we're going down the list of the domain part, the X's, it is never the same number. So we've got 4, 7, 6, 3, 5, 2. All of those are different. And so since all of those are different, then we can easily say that for every input, there's only one output. So this blue one here is a yes. This is a function. This green one up here, let's take a look at it. So we've got 54, 56, 55, 54, and 56. So because of this, and this, and then this, and that, this is a no. This is not a function. It's not a function at all. Okay? That makes sense? I hope so. Let's look at this same concept, but in a graph form. Let me kill these guys. Killed them. Stone dead. Dead. All right. Good job. So if we're looking at a graph, so ordered pairs again, or a line, something like this, or something like this. Those are both relations. Are they functions? Are they not functions? I don't know. Well, I do, but you probably don't know. So we're going to look at something called the vertical line test. The VOLT, the vertical line test. Right? We're going to illustrate this by looking at a set of ordered pairs that's graphed. So we have this one, and maybe this one, and that one, and then another point up over here, right? So if we're testing to see if these are functions, what we do is you can use your pencil or a ruler or whatever, and if as you're passing a vertical line, if there is never a place where this line touches the dots more than once. So see right here, it's touching the dot, but it's only touching one dot. So that's okay. And then we keep on going. If there's ever a place where the vertical line touches a dot more than once, then that's not a function. So if, say, we didn't have this guy, let's change to a different color. Let's go with this pink color. Looks great. So if we have like this, so say we've got those two, and then maybe one over here, and then one right here, and then one right here. So see, this fails the vertical line test because of this one and that one. Those 2 points, this vertical line, as we're passing it through, it touches the vertical line twice. So this pink one now fails the vertical line test, which means that this pink one is not a function. It's still a relation, right? We've still got two quantities, the x quantity, the y quantity, but it's not a function. Okay, so that's what a function is. It's a relation where for every input, there's only one output. Now, we're going to kind of briefly touch on a subtopic of this lesson, of this lesson on functions, called function notation. Function notation might be a little bit confusing at first. It's not that hard to use once you get the hang of it and once you get some practice and you understand the pieces of this puzzle and all of those things, but it can be tricky to understand at first. So function notation. Okay, so when we have a graph, right, and we're plotting points or we're drawing lines on it, which we're going to do plenty of things, we have the x-axis and the y-axis, right? And all of those things. So we might later be graphing something along the lines of y equals 2x. We might graph something like that. And then even later down the line, we might graph something like y equals 1/3 x squared, etc., etc., etc. And so function notation does, and it adds something more descriptive. Instead of, we don't use, oops, that's not what I wanted. This is what I wanted. It adds something to there that's a little bit more on the descriptive end. And what it does is it replaces y with f of x. Now, there's a couple of three things that I want to make sure that we say from the beginning strongly. First of all, this, as I just pointed out, we say this f of x. And that means that f is a function of x. And it tells us that f, or f of x, is the dependent quantity. And x is the independent quantity. Is the independent quantity. F is, and now I should note that it doesn't have to be f of x. It could be g of x or h of x or t of x or f of t or v of t. Oops. Like the variables can be different things and it still works. It's not specifically f of x. F of x is kind of the generic version, just like y and x are the generic variables that we use, or a and b or whatever. Now, one last thing I want to note before we do some problems using function notation in kind of a real simple way is that in this context, and context matters, just like, if we're learning to read English or whatever else, the context matters what the word means sometimes, right? Some words mean different things in different contexts. This has been true in math, and it is true now. If we have two numbers and we put a dot down here, it means one thing, and then if we put the dot up here, it means something else, right? That's maybe a bad example, but different contexts make different symbols and things mean different things. And what specifically the context here, this does not mean is if we have f of x, this does not mean f times x. It doesn't mean that. It means f of x. It means f is a function of x. It means f of x is the dependent quantity. It means x is the independent quantity. So those are some kind of high-level bits. Let's do some examples. I don't even know what example number this is. I'm not going to go back and figure it out. You got it probably right in your notes. It'll be easy for you to figure out the example number. It might be example like 3 or 4, but I'm just going to label it an example. Okay, so here's the type of problem we might see with this. And that is if f of x equals 4x minus 7, find each function value. Okay. So the first function value that we want to find is, this is part A of this example, is f of 5. So this is function f. It's 4x minus 7 equals f of x, right? And so what we do is basically this function's like a substitution problem, like any other substitution problem that we've ever done. And so what we do is we write the equation, but with parentheses everywhere there's a variable. And then into where the variable was, we're going to stick this number. So we're going to put a 5. And now we're going to simplify from there. So 4 times 5 is 20 minus 7. 20 minus 7 is 13, which means that f of 5 equals 13. So there's part A. Let's do part B of this same problem. Okay, we want to find f of negative 6. So we still have f of x to find up here in this particular problem. And so we're going to rewrite that guy with parentheses where the variable is. We're going to substitute this in for x. So we're finding f when x equals negative 6, right? That might be another way to state or phrase what we're doing here. So this equals negative 24 minus 7. As last bit, the signs are the same. We add and keep the sign. So this turns into negative 31. So f of negative 6 equals negative 31. Now, this will not be the last time in your math career that you see function notation. You're going to use it a lot moving forward and whatever else. They'll get some more complicated problems where we're taking one function and sticking it inside of another function, and we're adding functions together and subtracting them, etc., etc., etc. But for now and for today, this is what we're going to learn with functions. If you're one of my students, you are awesome, and I'll see you in class. Do your homework, all the things. Get caught up, stay caught up, be amazing. If you're not one of my students, thanks for joining us. Check out emberlearninglabs.com for everything else that we're doing. Don't forget to hit the like and comment down below what we can help you out with. And subscribe would be wonderful. Thanks. Have a great day. Bye-bye.